Hey friends, welcome to Chemistry Lover, and in this video I'll be talking about a very important topic, that is how to determine the molecular term symbol. So determination of molecular term symbol, it is a very important question, and very frequently in the csir-net exam this question is asked very frequently. So you can see I picked up this particular problem which is based on this particular topic, and there are several other questions. So I'll suggest you to watch this video till the end because it is very important. I will explain very briefly, and after watching this video you will be able to solve any question related to that. So let's start today's topic. So here you can see this particular molecular configuration is given. This is basically boron molecule, B2 molecule, and it is given, the molecular configuration is given, and you have to determine what is the term symbol for this molecule, right? So I'll solve this problem later, but first let me do the general discussion, that is how you have to approach the problem, or what is the procedure for determining the molecular term symbol. Okay, so first you should know how a molecular term symbol is generally represented. So this is, you can see, this is how the molecular term symbol is generally represented, but you have to know about the meaning of each of this term. So any molecular term symbol is generally represented as ml, and here it is 2s plus 1, here either it is g or u, and here plus or minus. Now what does this term mean? So this ml, modulus ml, this is actually the total orbital angular momentum. Okay, so this is the total orbital angular momentum. This s is the spin quantum number, and this comes from m's value, which is the total spin angular momentum. Okay, so to determine the molecular term symbol, first you have to calculate the total orbital angular momentum and the total spin angular momentum. How you can determine them? So total orbital angular momentum, ml, is the sum of individual ml values, that is individual orbital angular momentum values. So ml1 plus ml2 plus dot dot dot, and in the same way total spin angular momentum is the sum of the individual ms values. So ms1 plus ms2 plus dot dot dot. Now how this or from where this ml and ms comes? So let's say you have sigma orbital. So for sigma orbital, the ml value is 0. For pi orbital it is 1. For delta orbital it is 2, and so on. And you know ms value, so ms value can be plus minus half. So either ms value can be plus half or ms value can be minus half. So ms is very simple, but for ml value you have to know, for sigma it is 0, for pi it is 1. Similarly, as you learned from your determination of atomic term symbol, you know that for 0 it is s orbital, for 1 it is p orbital. Like the same way, if it is sigma orbital it is 0, if it is pi orbital it is 1, if it is delta orbital it is 2, and like that. And now what does this ml value mean? So now if you do the summation of this individual small ml value, you will get the capital ml value, and the modulus of this capital ml value again has a meaning, so it has a symbol. Okay, so if your ml is 0, this symbol is capital sigma. If it is 1, it is capital pi. If it is 2, it is capital delta. If it is 3, it is capital phi. So this thing you have to remember, that what value means what. Okay, now if up to this you understand, let me just take an example and do this. So For example, first start with simple molecules. For example, He2 plus. What will be the, or not 2 plus, He plus. So what will be the term symbol for He plus? So first let us see what is the molecular configuration of He plus. So for He plus it will be 1 sigma 2 and 1 sigma, so it is 1 sigma G. Okay, 1 sigma G2 and 1 sigma U1. Okay, so this is the molecular configuration of He plus. Now for determination of ml and ms value, for determination of this ml and ms value, you have to consider only those orbitals which are half filled. So here you can see this 1 sigma G orbital, it is completely filled, it is a closed shell, and this closed shell has no effect on the term symbol of the molecule, because if you calculate the ms value for this, so the two electrons which are on this sigma G orbital, they will have one plus half ms value and another will be minus half ms value. So if you sum up, you will get capital Ms is equal to 0. So for this closed shell configuration, it is always 0. Now for this half filled configuration, for this particular orbital, you will have Ms value is equal to plus half or minus half, right? So in every case, if you have given any molecular configuration, you have to ignore this closed shell. This closed shell has no effect on the molecular term symbol. And similarly, if you calculate the ml value, for ml value what you will get? For ml value, either way, sigma means it is 0, right? So another sigma, so 3 0, it will give you 0. So what I am trying to say is that while you are determining the molecular term symbol, you don't have to bother about this closed field or this closed shell, that is the orbitals which are completely filled. You don't have to bother about that. You only have to take care about the orbitals which are half filled. For example, here it is 1 sigma 1, here it is 1 pi u1 and 1 pi u1. So only those orbitals which are half filled, that you have to take care. Now, so here we get ms value is equal to plus half. Why we are taking plus half? Because we have to take the highest value of ms. According to the Holmes rule, we have to take the highest value of ms. So here both values are possible, either minus half or plus half is possible, but we will take the highest value, that is we will take the ms value plus half. And if ms value is plus half, that means a's value is also plus half, right? So ms is basically a's, and from that we will get 2s plus 1 is equal to 2 into half plus 1, that is 2. So we get 2. So here we write 2, and we can see the ml value here is 0 because sigma orbital is occupied, and for sigma we already told, for sigma ml is equal to 0. So total ml, that is total ml is equal to ml1 plus ml2 plus ml3. So here all are sigma, so it is basically 0, and 0 correspond to sigma orbital. So the configuration is 2 sigma. Okay, so the configuration here is 2 sigma for helium plus. Now let us see what is the configuration for the given problem. So in the given problem, we can see these two pi orbitals are filled, and for them we can calculate the ms. First we will calculate the ms value. So ms value is equal to ms1 plus ms2, and they can be either plus half which is equal to 1, or they can be minus half plus half which is equal to 0, or they can be minus half which is equal to minus 1. But we will take, we already told that we have to take the highest value of ms, and here the highest value is 1. So we have to take ms value is equal to 1, and this ms value is equal to 1, that means a's value is equal to 1. So 2s plus 1 is equal to 3. So it is a triplet state. Okay, now we have to determine what is the value of ml. So ml value can be, so similarly ml1 plus ml2, two electrons are there, so ml1 ml2. Now here for pi orbital, we already told that for pi orbital ml value can be plus minus 1, right? For pi orbital it is plus minus 1, for delta orbital it is plus minus 2, like that. Now here what are the combinations possible? So either it can be plus up plus 1 plus 1, that will give 2, or it can be plus 1 minus 1, that will give 0, or it can be minus 1 that will give minus 2. So ml has possible values of 2, 0 and minus 2. Okay, now we already told that we have to take the highest possible value for ml, that is 1, and that means they will have plus up configuration in each case. Now if we take these as both plus up, we cannot take same value for both ml, right? So this combination, that is ml value of plus 1 or minus 1 is not cannot be considered when we take this plus up value. So we only left out with only option, that is plus 1 and minus 1, that is 0. So by default here ml value becomes 0. So this thing I will explain again, that first we have to apply the Hund's rule, that is we have to take the ms value which is the highest ms value, and ms value is highest when both have plus up configuration, that is both are, let's say both with up spin. Okay, so if both are up spin, then we cannot take the same value for ml1 and ml2, because it is against the Pauli exclusion principle, which says that all 4 quantum numbers of 2 electrons cannot be same. So if we take both as up spin, then their ml values should be different. If we took one up spin, one down spin, then we could take it as 1 plus 1 or minus 1 minus 1. But as we are taking both as up spin, so we have to take one ml as plus 1 and another as minus 1. Okay, so that means ml value is 0 here. So this is allowed. So this ml value is 0 and ms value is 1, that means s is 1 and 2s plus 1 is equal to 3. So the term symbol will be 3 sigma. Okay, because ml 0 corresponds to sigma. So you can see all here it is given sigma. So and we also know that it is 3 sigma. So now this option and this option left out. So we are only left out with option B and option D. Whether it is 3 sigma G minus or 3 sigma G plus. Now the next task is to determine whether it is G or U. Okay, how we have to determine whether it is G or U. So if you have a configuration, for example, again we go to helium plus, where we had 1 sigma G 2 and 1 sigma U 1. Here you can see the contributing orbital is the sigma orbital and it has G symmetry. So it's previously we deducted that it is basically it is 2 sigma. Now as the sigma orbital here it is U, so by default it will be U, because only one orbital is there, so it is U. So if only one half filled orbital is there, the orbital which symmetry the orbital has, that symmetry the molecular term symbol will get. So here the sigma orbital has U symmetry, so molecular term symbol will also have U symmetry. But in this case you can see, so in this case we determined it is 3 sigma, and here you can see 2 pi orbitals are there. So both of them will contribute whether it is G or U, that is Gerade or ungrade. And you have to know that if you multiply U and U, you will get G. If you multiply G and G, you will get G. Only if you multiply U and G, then you will get U. So here both are U. So multiplication of them will give you G. So it is 3 sigma G, right? So it is 3 sigma G. And here it is 3 sigma U, because you have only one orbital to consider. So the symmetry which that orbital has, the same symmetry the molecular term symbol will also have, right? Now we have to determine whether it will be plus or minus sign. So for determination of plus and minus sign, we have to check whether the contributing orbital is changing its sign with respect to a given arbitrary plane or not. What is mean by that? So for example, let's say we consider pi orbital. So let's say this is a pi orbital and this is the axis. So this is your x axis, this is your y axis, and this is your z axis. So here this is the molecular axis, this is the molecular axis, and this is also the z axis. Okay, now you have to consider two planes, either yz plane or xz plane. So here this is the pi u orbital, you know, this is the pi u orbital, and if we consider the yz plane, that is this plane, you can see this is the yz plane, and you can see the two sides of the plane. So upper side of the plane has black lobe, whereas the downside is white lobe, or it may be minus and plus. So with respect to this plane, the pi orbital is changing its sign, right? But if we take another plane, so it is a pi orbital, it is plus, it is minus, and in this case we are taking the xz plane. So if we consider xz plane, you can see with respect to that plane, the pi orbital doesn't change its sign. Now this one pi u orbital, if one is px, then one pi u, another will be your p 2py, right? So if you consider this 2 pi orbital, one will change its sign with respect to the given plane, and another will not change its sign. So whenever you have 2 pi orbital, one will always change its sign and another will not. So that means one will be positive and one will be negative. So the pi orbital which change its sign with respect to a given plane, that is given negative, and which doesn't change, that is positive. So here by default one will be positive and one will be negative, and multiplication of positive and negative is always negative. So that means here it will be negative sign. So option B is the correct answer, triplet sigma Gerarde and negative. Now for helium, it is sigma orbital, and whether you take sigma bonding, so that is sigma g, so it is your sigma g, and if you consider any plane which is coincident with the molecular axis, there will be never will be any change in the sign of the orbital. Or if you take sigma star or sigma Ungerade, so this is your sigma star or sigma Ungerade, again it is cylindrically symmetrical, so there will be no change in sign. So for sigma g or sigma eu, the sign will be always positive, but for pi orbital, if 2 pi orbitals are there, it will be always negative, but if only one pi orbital is there, then it will be positive, right? So this is how you have to determine the term symbol for a particular molecule. So let me summarize the thing once again. So first what you have to do, so the first thing what you have to do is you have to determine the ms value, capital ms value, that is total spin angular momentum. How you can determine that? You have to sum up all the spin, all the possible spin, that is all plus up minus up, and you have to take the highest possible value of capital ms. Next thing you have to do is that you have to take the summation of ml values, all possible ms values, and you have to determine the capital ml. So now according to the value of capital ml, if it is 0 it is sigma, if it is 1 it is pi, and so on. So you determine it is n sigma, that is n means 1, 2 or 3, so you determine 2s plus 1. So you determine 2s plus 1, whether it may be sigma, pi or delta. Now the next thing you have to determine is that the orbital, it is Gerarde or Ungerade. If only one orbital is singly occupied, or only one half filled orbital is there, the orbital whatever its symmetry is, Gerarde or Ungerade, that will be here. So if it is, let's say it is sigma g, here you will have g. The next thing, if there is two singly occupied orbital, you have to multiply their symmetry, that is g into g will give you g, u into u will give you u, u into u will give you g, and g into u will give you u. So you have to determine that, and then you have to determine whether the orbital is symmetric with respect to a particular plane or not, and the shortcut is that sigma orbital is always symmetric. So if you have only half filled sigma orbital, then your sign of the term symbol will always be positive, and if you have one pi orbital, you cannot determine the sign of the orbital, but if you have 2 pi orbital, then their multiplication will always give you negative. So this is the summary, and I think you will be able to solve the related problems on that. If you have any doubt, let me know in the comment section. I will try to clear them. So thank you for watching, and if you are new in this channel, then subscribe my channel.